Welcome to the WTR Small Cap Spotlight podcast. I'm your host, Tim Gerdeman, Vice Chair and Co-founder and Chief Marketing Officer of Water Tower Research. In today's podcast episode, I have the pleasure of being joined by Rod Baltzer, CEO of Deep Isolation. The company operates as a public reporting company, but their stock is not listed on an exchange at this moment. Also joining is my WTR Equity Research colleague, Eric Goldstein. Deep Isolation is an innovative nuclear waste disposal technology provider dedicated to protecting human health and the environment. The company has pioneered a patented, directionally drilled deep borehole disposal system that safely secures spent nuclear fuel and high-level radioactive waste deep into the Earth's crust. Its technology, highlighted by the universal canister system, offers governments, regulators, and commercial organizations a flexible, cost-effective solution to the global nuclear waste crisis. Deep Isolation combines deep technical engineering with robust community engagement to ensure that its repositories align with both safety standards and local values. So with that, welcome to today's podcast, Rod and Eric. Good morning.
Morning.
Good morning.
Rod, let me start by asking you to tell our listeners about Deep Isolation. More specifically, perhaps you can give us a high-level overview of what the company does, the core business, the problem you're solving for with customers, and why the disposal of spent nuclear waste has never been permanently resolved previously.
Thanks, Tim. Yeah, so Deep Isolation has leveraged directional drilling to take commercial spent nuclear fuel out of reactors, put it into our universal canister system, and deploy it about a mile deep underground. It can be located with reactors or other waste storage sites. It can be regional repositories or utilized and tailored to whatever the customer's needs are. So Deep Isolation got founded 10 years ago. We've got over 100 patents across our technology lifecycle. How do you characterize a site? How do you design the well? How do you design the canisters, monitor that during and after operations? And finally, how you close that well for long-term safety. What's been fascinating is that the world has never disposed of any spent nuclear fuel anywhere in the globe. Finland will be the first. They've constructed their mined repository. It took them over 20 years and 10 years just for construction. But Deep Isolation can now drill these in 2 months. So it is a much faster process. You can do this modularly. You don't have to do it all at one time. So we're bringing a lot of innovation that nuclear waste hasn't seen in a while.
Excellent. Thanks for that overview, and certainly a very important problem you're trying to solve for. So with that, I'll turn it over to Eric to ask a few questions.
Okay, thanks, Tim. And thank you, Rod, for joining us today. We appreciate your time. So if we just take a step back for a second, just to your original involvement with the company, you came in as the Chief Operating Officer, and after that became the CEO as the company was ready to start scaling up operations. So what drew you to this mission, and how has that vision evolved since your early days with the company?
Yeah, I got kind of lucky. I grew up on a dairy farm. I went to school, became an accountant, and decided that public accounting maybe wasn't for me, and was looking for that next job. And I was at Waste Control Specialists, which did low-level radioactive waste. I'd come up through the finance side of the organization, and this company called Deep Isolation walked into my office and asked how we had gotten our licenses and integrated into the community, and how we had kind of achieved an operating low-level waste facility. And when we sold Waste Control to private equity, Elizabeth Muller, one of the co-founders, reached out and said, "Hey, do you remember us?" I said, "Of course. Would you like to do in high-level waste exactly what you did in low-level waste?" I said, "Yeah, that sounds great. Let's go tackle this problem." And so that's how it kind of got started. And so we started as this young company with a concept and an idea to somebody who's now demonstrated this in physical demonstrations, gotten a lot of, over $6 million of ARPA E grants and other financing to kind of make this technology more commercially available.
Okay, that's great. So, as you alluded to previously, you're dealing with a problem that nobody has solved yet. So there are over 90,000 tons of spent nuclear fuel sitting at reactor sites across the US alone. And the world collectively has never permanently disposed of a single gram of any of this waste. The Yucca mountain site that was selected in 1987 has effectively been abandoned. Finland, as you mentioned just before, the Onkalo site took 20 years and 5 billion euro to build. So why has this problem been so difficult to solve for so long? And why is now the moment?
Yeah, I think there's been several things that have kind of impacted this. Part of it is, not in my backyard. So Yucca Mountain, Nevada, it's about 60 miles from Las Vegas. And they did not want transportation near Las Vegas for tourism and other aspects. Nevada didn't have nuclear reactors, and so all the commercial spent fuel from around the nation was heading there. The local county was very supportive jobs and economic growth, but Las Vegas and the broader state of Nevada were not. And the administrations change and priorities change and budgets change, and that's just not helpful for a long-term project. But none of that's unsolvable. This is something we can fix. And what we've seen recently is the Department of Energy issued nuclear life cycle innovation campus requests. And 26 states said we'd be interested, at least in talking about a disposition path in our state. But a lot of them were, we don't want to be the nation's waste, but we're interested in what we can do in our state. And I understand DOE's trying to narrow that down to 3 to 5, but it's interesting. Some of these states already have waste in their backyard. And so instead of, what are you going to, instead of not in my backyard, the waste is already in your backyard. What are you going to do about it? And that really changes that conversation, I think.
Okay, great. So let's dig into the technology a little bit. So can you walk us through the borehole concept, the canisters, the directional drilling, the depth, the geology? What makes this fundamentally safer and more practical than a mined repository? And why didn't anyone think to apply directional drilling technology to this problem before?
Eric, that's probably the number one question we get. How come nobody thought of this before? And it does, make you kind of think about it. I think the main reason is that the nuclear industry didn't really talk to the oil and gas industry. And so nuclear had looked at boreholes, but this was back in the early 80s, and they thought you had to be straight vertical into crystalline granite, 5 kilometers deep. And oil and gas subsequently was perfecting directional drilling, following formations, and it learned a lot, but nuclear never looked back. And so when deep isolation came along, we looked at directional drilling, and that's what kind of helped. When we talk about this, really, we're talking about a roughly mile deep borehole. We think we could be into a clay formation, salt, could be into granite. It doesn't have to be horizontal. It can be directional or slanted, deviated, other well types. But we're about 22 inches diameter at depth, so that's larger than your typical oil and gas well, but it's within the technical bounds. We collaborate with Halliburton as our drilling expertise, and we're testing our equipment and tools and things at their facilities, and so we're excited about that. The other thing you mentioned was our universal canister system, and so this is a canister that's about 16 feet long, and it's got a kind of skinny neck at one end. You might liken that to kind of a Coke bottle, but we call that the lift adapter. And that lift adapter was designed to work with both nuclear equipment and oil and gas. We want to make sure you don't drop it. So, if you're going to move that from a truck or something onto your facility to the wellhead and then in place it, that all links. But it's designed for storage, transportation. You can dispose of it in a mined repository or a deep borehole, never have to repackage it. If we had to repackage the waste in dry casks already in the US, that's $30 billion plus the radiation dose. And so this kind of future-proofs it. It's also compatible with both the legacy fleet, light water reactor fuel, and the new advanced fuels like TRISO, molten salt, even reprocessed waste streams, recycled waste streams.
It's great. So can we actually just dig into the canister system a little bit more, which you were just talking about? So that seems like it's one of your more important innovations. It has a triple purpose, as you said: storage, transportation, disposal without repackaging. So how significant a breakthrough was that, and what exactly did it take to get you there?
Yeah, we've collaborated very closely with NAC International. For those who are not familiar, they're one of the three major dry cask manufacturers in the US. They also do a lot of transportation and storage for the Department of Energy with defense waste streams. And so when we collaborated with them, we wanted to make sure that we would meet all the nuclear safety standards. And we had to, look at pressures and stresses on the canister for moving and emplacement, transportation and storage, the criticality of it. What's unique about this canister is that it's pretty thin walled. We don't provide the shielding with the canister, but with the equipment that handles that. And so that's what shields and protects the workers and public and whatnot as we move it around. But that was designed so that it would be skinny enough to fit in a borehole without having to make that borehole extremely large, robust enough to handle that waste. And then it's made of a duplex stainless steel. So nothing too elaborate, but it does provide corrosion resistance and a good engineered barrier to hold that waste form in.
Okay. So you've gotten some validation from the Department of Energy. You've secured over $6 million in DOE and in ARPA E grants. You have some impressive partnerships with the Argonne National Lab, Lawrence Berkeley, OCLO, and NAC International. And most recently, you demonstrated the borehole disposal works for recycled advanced reactor fuel. So how does the government validation change the conversations you're having commercially?
Yeah, one of the things Deep Isolation wanted to do is make sure that we had technology that was, I'll say, vetted by others. It wasn't just Deep Isolation saying our technology works, you ought to check it out. So we've been able to apply to ARPA E grants for the ones you've mentioned. We work with Oklo and also Argonne National Lab with some of that technology for Oklo's reprocessing facilities, recycling facilities. And our canister, we looked at, okay, if you put their fuel in our canister, can you dispose of it safely? How does that work? What does that look like? What are the economics in that? And over our shoulder, ARPA E was looking, and they've got a lot of technical experts that are really sharp. And so we've got a lot of milestones and reports, and that was able to really kind of sharpen our edge as we designed this to make sure we had a really nice finished product at the end of that project.
Okay, so let's turn to your demonstration facility in Cameron, Texas. So in January of this year, you broke ground on a full-scale demonstration program at the Deep Borehole Demonstration Facility near Cameron in Texas, with local government and industry in attendance, I believe. So there was no radioactive material being used, but it seems like a critical step towards building regulatory confidence. So what does that program prove, and what does success look like for you?
Yeah, this groundbreaking was something that we've known for years we needed to do. We asked our customers, what's the number one thing we could do, and they said a full scale end-to-end demonstration. They like the technology on paper, but they need to bring communities and regulators and others out and really kick the tires, see it in action, and see it actually operating. And so we've been trying to raise money, and I think we'll talk about that, but we decided to kick that off on our own. Subsequently, we were selected by ARPA E Scale Up Ready for a $20 million award that we're in the process of negotiating contracts on to expand that. And so now we can do both not only the subsurface, which we kicked off in January with long lead items, but also the surface handling. That also allows us to collaborate with Westinghouse and their Vinci reactor, which is TRISO based. And so we can use that fuel specifically to get NRC certificate of compliance for that fuel in NAC, MagnaStore, Magnetran for storage above ground and transportation, and then demonstrate how that would be disposed of in a borehole. It'll all be non-radioactive, but we use surrogate materials for center of gravity and weight and things like that.
Okay, that's great. So let's talk about the size of the market and the opportunity you guys are looking at. So I believe you've described the market as potentially $155 billion globally, and that could double by 2050. Between the legacy waste backlog and then new nuclear builds, for data centers and just for cleaner sources of energy in general, and international demand, where are you focusing first? And how does the 70% cost advantage over mined repositories change the conversation you're having with your potential counterparties?
When we look at kind of globally what happens in nuclear, generally the nuclear utilities are charged a small fee and they pay it into a nuclear waste fee. And there is a radioactive waste management organization in that country that's responsible for disposal, perpetual care, and ownership of that waste over the long term. In the US, that entity is the Department of Energy. And so there's about 40 countries that have nuclear power and are looking at it pretty seriously. And so we're engaged with all of them to make sure they know about deep isolation, that we're out here, we're ready to help. Some of those we've integrated a lot more with, and we've done studies specifically for them. But that pipeline's pretty manageable since we think we've got about 40 customers around the globe. But you're right, it's still a really big market as that waste continues to be generated, and then we start adding to that fleet. That market doubles by 2050 to almost $300 billion, and that's at a borehole market. If that was a mined repository, it'd be $1 trillion. So by not having people underground, not having to worry about ventilation and a lot of engineered barriers, we're able to do this a lot cheaper and faster, but we're still twice the depth of a mined repository, so we're also safer. And so, we hit a lot of boxes. The only box we don't tick is not everything will fit in a mined repository, or not everything will fit in a borehole. Some of the Navy reactor waste and some of those are just too big physically to fit in a borehole. So we'll still need a mined repository, but it can be a much smaller one than what we might have planned otherwise.
Okay, so let's talk about your partner ecosystem. So you've built a pretty impressive list of companies that you've been working with. You mentioned Halliburton, Amentum, Navarro, NAC International. So these span drilling, execution, federal contracting, and then of course the canister manufacturing. So you've licensed technology to Navarro for Tennessee and Idaho, and you're working across a dozen countries on 3 continents. Is the core business model to license your IP, direct project execution, or both?
Yeah, your listeners should probably think of us as an IP company. We've got the technology, but we've really offered customers a choice. We've got a supply chain partnership, and we can come in and do a turnkey job. Most customers seem to like that idea. But if you've got a national oil company and you want them to drill for you instead of our supply chain partner, that's perfectly fine. We can still provide the technology and know-how and expertise to make sure that's done right. But that's just the IP license that would come out. But this allows us to be asset light and leverage, those who have the expertise instead of trying to duplicate that expertise in-house. That's kind of like, everybody's looking at AI and other things and how do you integrate this into the future. And we want to make sure we've got, those traditional industries like oil and gas drilling that also have a nuclear future as we continue to expand that as well.
Okay, makes sense. So let's take a look at the SMR opportunity. So the advanced reactor and SMR wave has certainly been accelerating recently, but it's not clear that they've dealt with the back end of the fuel cycle also. So does the industry risk repeating mistakes that were made 50 years ago? How are you positioning deep isolation as the go-to waste solution for SMR developers who are raising billions of dollars today, but also will have a waste problem in the future.
And new nuclear doesn't work without solving the waste problem. And we think we can solve the waste problem. So we are working with a lot of the new SMR companies. This contradicts, I just told you a couple of questions ago that our customer is a government entity. So why are we working with them? Well, we want to make sure that as they're thinking about their product, how are they going to store that waste? We want to make sure they're going to store it in that universal canister so nobody has to repackage that. So thinking about that waste up front may save them a lot of money. For the new SMRs, they'll have to sign an amended standard contract here in the US to operate. And that's contract now is going to make them pay for storage during the entire life of operations plus 10 years. So that can be up to 70 years of storage cost. So being able to make sure you've got it in the right canister, in a right storage configuration so that it's ready for disposal as soon as possible, and open up those disposal possibilities is key to keeping your cost of energy down and making sure your product's one that can get marketed the best in the very competitive field of SMRs out there. I'll just add on to that. What's interesting is there's a lot of SMR companies. I think last count there was like 70 some odd different designs, but there's only one waste borehole company, and that's Deep Isolation, and that's globally. We just really don't have competition in this space. And so as you look at nuclear, we want to be technology agnostic, where our technology fits with everybody and provide that solution, make sure we can provide the right, environmental support that's going to be needed at the end of this.
Okay, that's great. So the last question then. So let's think about the road ahead. So you went public in July of last year when you raised $33 million in an oversubscribed private placement. So you now have capital to fund your full-scale demonstration. What are the key milestones over the next 2 to 3 years? NRC engagement, first commercial site, potentially international deployment. And what does deep isolation look like when this technology reaches scale?
Yeah, we've started those NRC discussions. The Nuclear Waste Policy Act in the U.S. says only DOE can get a license, and it can only be at Yucca Mountain. We understand there's discussions in the industry and on Capitol Hill about the potential to change that with these new nuclear life cycle innovation campuses and the state interest. It's time, and so we're encouraged by that. We see that as good possibilities. As we look out to the future, one of the reasons we're a public company and raising this money is the need to scale. If we've got that many states interested and we need to go and start discussions with them, then we need to grow the company. And we think we've got a good baseline for that and are poised for that growth in the future.
Okay, Rod. Well, thank you so much for walking us through the deep isolation story. It seems like you have a very, very bright future. And you're working, obviously on a very good cause. And so just want to wish you the best of luck and thank you for joining us. And now, Tim, back to you.
Thanks, Eric. And Rod, thanks so much for joining us today and explaining Deep Isolation's business model. What a huge total addressable market in such a niche area. You don't see that combination very often. So really interesting and really appreciate your thoughts today.
Thanks for having me on. It's been a pleasure.
Thank you for listening, and don't forget to subscribe, as well as visiting www.watertowerresearch.com to stay up to speed on the company's small cap written research reports, podcasts, fireside chats, industry-specific symposiums, and conference schedules. We will see you next time for another edition of the WTR Small Cap Spotlight podcast. Finally, a special thanks to the producer and editor of the podcast, Krista Fitzpatrick.